This is SpaceTime Series 24, Episode 27. Coming up on SpaceTime, a change in dark energy. NASA's Parker Solar Probe swoops past Venus at 87,000 kilometers per hour. And a new eye in the sky to monitor Amazonian deforestation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The universe was created 13.82 billion years ago in the Big Bang, and it's been expanding ever since. That expansion, which is still going on today, sees the cosmos being stretched out in all directions like a balloon being inflated. And thanks to a mysterious force called dark energy, that rate of expansion is increasing. It's called dark energy because physicists have no idea what it is, hence the term dark, as in unknown. They know dark energy is stronger now than what it was billions of years ago, and that's affecting the rate at which the universe is expanding, a figure called the Hubble Constant. And this is where things start to break down. Measuring the expansion rate of the universe in different ways gives you different results, and that shouldn't be happening. Astronomers can measure the Hubble Constant by using two methods. The first observes things like Cepheid variable stars and Type 1a supernovae in the local universe. These give you an expansion rate somewhere around 74 kilometers per second per megaparsec, a megaparsec being a million parsecs or 3.3 million light years. It works because Cepheid variable stars pulsate, that is, expand and contract, at a set rate based on their intrinsic luminosity, and so they can be used as standard candles to measure cosmic distances. And so because astronomers know how intrinsically luminous a Cepheid variable star is because of its pulsation rate, they can determine how far away it is. Just like a row of streetlights all have the same brightness, but the ones further down the road appear dimmer than the ones nearest to you. And the same goes for exploding stars called Type 1a supernovae. These stars all explode at about the same mass, and so with roughly the same amount of brightness. And so, like Cepheid variables, they can be used to determine cosmic distances. The second method for determining the Hubble constant uses measurements of the cosmic microwave background radiation, when the primordial cosmos cooled enough for the first atoms to form, and for the first photons of light to escape, about 380,000 years after the Big Bang, which, according to measurements by the European Space Agency's Planck spacecraft, is much slower than the supernova value for the Hubble constant, just 67 kilometers per second per megaparsec. Assuming the lambda cold dark matter standard cosmological model of the universe is correct. Having two different numbers for the Hubble constant means science's understanding of cosmology is missing something. Now, a new hypothesis, reported in the journal Physical Review D, suggests the answer could involve a new type of dark energy. Dark energy is a mysterious force which is causing the universe's rate of expansion to accelerate. When physicists calculate the expansion rate of the universe, they base their calculations on the assumption that the universe is made up of dark energy, dark matter, and ordinary matter. Until recently, all types of observations fitted in with such a model of the universe's composition of matter and energy. But as things are getting more and more precise, that may no longer be the case. The study's lead author, Martin Sloth from the University of Southern Denmark, says adding a new model of dark energy to the various calculations on the expansion of the universe results in less variation in the Hubble constant. Sloth and co-author Florian Niederman suggest that if there's a new type of extra dark energy in the early universe, it would explain both the background radiation and supernova measurements simultaneously, without contradiction. They hypothesize that in the early universe, dark energy existed in a different phase. Sloth says you can compare it to water when it's cooled, and it undergoes a phase transition to ice with a lower density. In the same way, dark energy in this new model undergoes a transition to a new phase with a lower energy density, thereby changing the effects of the dark energy on the expansion of the universe. According to Sloth and Niederman's calculations, the results add up if you imagine that dark energy thus underwent a phase transition triggered by the expansion of the universe itself. It's a phase transition where many bubbles of the new phase suddenly appear. And when these bubbles expand and collide, the phase transition is complete. Sloth says it's a very violent quantum mechanical process on a cosmic scale. This is SpaceTime. Still to come, NASA's Parker Solar Probe has just undertaken its latest close flyby of the planet Venus, swooping above the Venusian surface at 87,000 kilometers per hour. And there's a new eye in the sky to monitor Amazonian deforestation. All that and more still to come on SpaceTime. NASA's Parker Solar Probe has just undertaken its closest flyby of the planet Venus. During its last pass in July 2020, the spacecraft captured some stunning views of the shrouded world. Though Parker Solar Probe's focus is the Sun, Venus plays a critical role in that mission. See, the spacecraft swoops past Venus 7 times over the course of its 7-year mission, using Venus's gravity to bend the spacecraft's orbit. These Venus gravity assists allow Parker Solar Probe to fly closer and closer to the Sun on its mission to study the dynamics of the solar wind close to its source. But along with the orbital dynamics, these passes also yield some unique and even unexpected views of the inner solar system. During the mission's third Venus gravity assist back on July the 11th, 2020, the onboard wide-field imager for Parker Solar Probe, or WISPR, captured a striking image of the planet's night side from just 12,400 kilometres away. Now, WISPR is designed to take images of the solar corona and inner heliosphere in visible light, as well as images of the solar wind and its structures as they approach and fly by the spacecraft. But as it focused on Venus, WISPR detected a bright rim around the edge of the planet. It may be a form of night glow, light emitted by oxygen atoms high in the atmosphere as they recombine into molecules on the night side. But surprisingly also visible was Aphrodite Terra, the largest continent on the Venusian surface. Although hidden below the cloud tops, its 30 degrees Celsius surface temperature is far lower than its surroundings, resulting in thermal emissions of the giant continent below being visible. The observation was a surprise, as scientists weren't expecting WISPR to be capable of seeing into the near-infrared. And this unexpected ability has sent WISPR scientists back to the drawing boards to find new research opportunities to study dust around the Sun and in the inner solar system. Other than our moon, Venus is by far the brightest object in the night sky. Venus is often called Earth's sister planet. That's because both worlds are similar in size and mass and were formed under similar conditions in the same part of the solar system. But they've evolved in very different directions. Venus's thick atmosphere, composed mainly of carbon dioxide, keeps its surface at a temperature of around 460 degrees Celsius. And that thick cloud cover means Venus's surface pressure is 100 times higher than on Earth. The upper atmosphere is home to multiple cloud layers made of sulfuric acid with traces of water, which move at hurricane-like speeds. Despite this hostile environment, the recent discovery of what could be phosphine molecules in Venus's atmosphere has reactivated speculation about the possible presence of aerial microbial life. Although if you're a regular listener of SpaceTime, you'll know that hypothesis has been dealt somewhat of a blow in recent weeks. Spacecraft passing close to Venus as they travel through the inner solar system can gather valuable data to help scientists understand the planet's properties and evolution. In fact, the European Space Agency's Bepi-Colombo spacecraft undertook the first of 2 Venus gravity assist flybys in October 2020 on its way to Mercury. And it will carry out a second, more daring flyby on August the 10th this year, when it will cruise just 550 kilometres above the Venusian surface. Meanwhile, Japan's Akatsuki spacecraft is continuing its own orbital mission of Venus, studying its clouds and surface using cameras in infrared, visible and ultraviolet wavelengths in order to investigate Venus's complex meteorology and its mysterious atmospheric superrotation. See, on Venus, the planet rotates at a fairly lackadaisical 6 kilometres per hour at the equator, but its atmosphere spins around the planet at 300 kilometres per hour. Other experiments are designed to look for lightning and confirm active volcanism on Venus. During its latest flyby of Venus a couple of days ago, Parker Solar Probe swooped down to 2,385 kilometres above the planet's surface, travelling at some 86,900 kilometres per hour. It was the fourth of 7 planned Venus gravity assists, and it helped set the spacecraft up for its 8th and 9th close passes of the Sun, which are slated for April the 29th and August the 9th. During each of these solar passes, the Parker Solar Probe will break its own record as it comes to within 10.4 million kilometres of the apparent solar surface. That's some 3 million kilometres closer than its previous closest approach back on January the 17th. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says Parker Solar Probe's current encounter with Venus is taking place at a time when the planet is behind the Sun and hidden from view from Earth.
It's an amazing space mission. It's going closer to the Sun than any spacecraft has ever been before, and scientists are particularly interested in taking measurements inside the Sun's corona, which is sort of its outer atmosphere, where although the gas is really thin, it's really hot. So what gas there is, it's not even a gas, it's a plasma really, I suppose you'd say. It is really, really hot, much hotter than the temperature that we consider to be the surface of the Sun. That's much, much cooler by comparison. As you can imagine, with a spacecraft being sent close to the Sun, it's got some pretty heavy-duty heat shielding on it to keep all its bits and pieces insulated from the extreme heat. One thing I was really intrigued to learn, though, however, is the heat shield is so good that they've actually had to put an electric heater on board to keep some of its electronics warm.
Oh, no, really?
Because it would get too cold. Can you believe that? So on one side of this heat shield, you've got the most intense heat you'd ever come across, well, what we'd never ever come across, but any spacecraft has ever come across before. And on the other side, it's so cold, they actually need little electric heaters, solar-powered heaters, to keep the electronics from freezing up. So you've got this heat shield, and some of the little instruments can just poke their head around the corner a little bit and take their measurements and then come back in again. So it really is the most amazing engineering to be able to do this. It's just staggering. I'm always in awe of what these spacecraft designers and engineers can do in the most extreme environments, and building these things so robustly that they work. And because you can't go out and fix them, so they just have to work, you know. That's why they put backup systems on board and everything else, but they have to build them so robustly in the first place. That's why it takes a long time to do missions, and why they can be quite expensive, because they've got to use all the good gear and all the most, the best equipment, which is usually the most expensive, and they test them till the cows come home to make sure that they will do the job that they're meant to do. So an amazing mission, Parker Solar Probe. It's going to continue for years and learn more and more about the Sun, because, of course, the Sun is very important to us here on Earth.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is Space Time. Still to come, a new eye in the sky to monitor Amazonian deforestation. And later in the science report, a new study finds that a third of all COVID-19 patients are still suffering symptoms 9 months later. All that and much more still to come on Space Time. India has launched a new Brazilian Earth observation satellite designed to monitor the worsening problem of Amazonian deforestation. The Amazonia 1 was launched aboard an Indian space research organisation Polar Satellite Launch Vehicle from the Satish Dhawan Space Centre on the Bay of Bengal coast. For this mission, the 4-stage PSLV included 2 strap-on boosters.
3, 2, 1, 0. Plus 5 seconds.
Majestic liftoff and the announcement of normal liftoff from the Range Operations Director.
सफलतापूर्वक उत्थापन PSLV 51 का
19 satellites taking a ride in this mission. Amazonia 1 being the prime satellite.
Stage performance normal.
PS1 performance is according to the expectation for this mission. Both the strap-ons have ignited on ground. It's 1 minute 15 seconds into the launch. Altitude 40 kilometers. All the ground-lit strap-ons are separated.
Stage performance normal.
Core stage will continue to burn for 1 minute 50 seconds.
PSLV C51.
First stage separated, second stage ignited,
Dvitiya
second stage
charan.
performance normal.
About 90 kilometers altitude already attained. The PS2, the second stage of PSLV, operating currently. The second stage operation increases the relative velocity of the launch vehicle. The payload fairing has been separated and the closed loop guidance also is initiated. These are the two events which are done after the launch vehicle clears the denser part of the atmosphere.
Second stage performance normal.
The Shah's tracking station is continuing to track and Trivandrum station also has started to acquire the signal of launch vehicle flight. The second stage of PSLV is based on liquid propulsion system.
Second stage separated, third stage ignited, third stage performance normal.
Close to 5 minutes past the launch, the PSLV third stage is currently operating and the performance is normal.
Plus 5 minutes.
This stage is a solid propellant motor. Its height is 3.6 meters, diameter 2 meters and uses 7.65 tons of propellant. The third stage will continue to burn for 125 seconds, that is a little over 2 minutes. In this duration, it will add 8 kilometers to the altitude but increase the relative velocity from 3.8 to 5.8 kilometers per second for the mission requirements.
Third stage action completed.
Now, though the third stage has completed its action, it continues to coast along with the fourth stage and the spacecrafts. It will do so for the next 1 minute 47 seconds, during which time there is 143 kilometers gain in the altitude as the launch vehicle loses velocity trivially. Senior government officials are here to watch the launch.
Plus 8 minutes.
Third stage separated.
प्रज्वलन होगा.
Engine started.
The launch vehicle is more than 1,400 kilometers away from the launch port.
Fourth stage performance normal.
Plus 9 minutes.
Fourth stage is performing normally and the Trivandrum and Mauritius tracking stations are presently tracking. The tracking of today's mission for the launch vehicle is carried out by ISRO Telemetry, Tracking and Command Network, a host of ground stations in the flight path of the mission. Particular to this mission, 5 stations are tracking for 2 orbits. For the duration of 2 hours and 11 minutes, there is overlapping visibility of flight from these tracking stations.
Performance normal.
SDSC Shar, Trivandrum, Mauritius, Antarctica for both the orbits, and the Lucknow station in India will join exclusively for the second orbit.
Amazonia 1 is the first Brazilian optical Earth observation satellite to be launched by India. The 637-kilogram spacecraft was deployed into a 750-kilometre high sun-synchronous orbit. Amazonia 1 will use visible and near-infrared cameras to monitor deforestation in the Amazon and study agricultural and land use developments. As well as the primary payload, the PSLV C51 mission also carried 18 smaller rideshare satellites from the United States, India and Mexico. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study following up on 177 COVID-19 patients has found that a third are still experiencing symptoms 9 months later, even if they only had a mild version of the disease. The study also found that around 1 in 12 patients found that COVID-19 was continuing to negatively impact their ability to go about their daily lives, especially in terms of being able to do household chores. The most commonly reported specific symptom was fatigue, which affected around 1 in 7 recovered patients. The findings, reported in the Journal of the American Medical Association, suggest that the health consequences of COVID-19 extend far beyond acute infection, even among those with only mild illness. A new study reported in the Journal of the American Medical Association has supported numerous previous studies which have found that consumption of red meat and alcohol increases the risk of bowel cancer. The new research has brought together data from 45 previous studies looking at diet and bowel cancer. The authors found that dietary fibre, yogurt and foods high in calcium are likely to reduce the risk of bowel cancer. Palaeontologists have confirmed the discovery of Australia's earliest skink. A report in the Journal of the Royal Society Open Science says a fossil of the ancient lizard was unearthed in the remote Namba Formation in outback South Australia. Scientists from Flinders University and the South Australian Museum say the 25 million-year-old specimen they uncovered is an ancestor of today's blue-tongue lizards. The remains consist of just a skull small enough to fit on a teaspoon and a set of microscopic-sized bones. A new study has found that the Netherlands, the United States, Australia and New Zealand are consuming the highest amounts of designer party drugs. New psychoactive substances include a range of party drugs designed to mimic established illicit drugs such as cannabis, cocaine, MDMA and LSD. The findings, reported in the journal Water Research, looked at the pattern of designer drug use over the 2019-2020 New Year holiday period. That's before COVID hit. It focused on 14 sites across Australia, New Zealand, China, Spain, Italy, Norway and the United States. Of the 8 countries studied, only Norway showed no traces of party drugs. Makes you wonder what's going on in Oslo, doesn't it? On the other hand, the Netherlands recorded the highest usage, closely followed by Australia and then New Zealand and the United States. Spain, Italy and China had the lowest incidence of designer drug use in cities participating in the study. N-ethylfentanyl, which is known to cause fatalities, was seen in Australia, New Zealand and the United States. It had previously been detected in forensic samples and at music festivals in Australia and New Zealand. Another designer drug called mephedrone, often referred to simply as drone or white magic, sometimes meow meow, was found only in Australia and New Zealand, with Kiwis recording a 20-fold spike in usage on New Year's Eve. It's a drug which produces similar effects to those of cocaine and MDMA and is popular with ecstasy and stimulant users in Australia and New Zealand. The Netherlands recorded traces of 6 of 10 quantifiable drugs. 7 additional recreational drugs were also identified in the samples after screening. Of these, ketamine and its metabolite were found in every country. A newer drug on the market, Eutalone, was seen in Australia, New Zealand, the United States and the Netherlands. Well, it appears to be a case of African déjà vu all over again. This time, it's the president of the East African nation of Tanzania who's warning his people against using COVID-19 vaccines. Instead, he's calling on the public to pray and use traditional remedies such as steam inhalation. Tim Mendham from Australian Skeptic says the president claims there's been no cases of COVID-19 in Tanzania for a year, but then again, his government hasn't published any figures on COVID-19 since May the 8th, 2020.
Obviously, Tanzania, not being a very large country, is not producing its own vaccine, so they're supposed to be relying on other people, other companies, etc., other countries to supply it. But there's certainly doubt in the mind of the Tanzanian president, who would say that they shouldn't trust overseas companies. He's even saying that if they were genuine, if the vaccine developers were genuine, they would have already brought us vaccines for cancer and TB and malaria. So he said, be very careful of what you bring from outside. We don't trust them. Don't think that they love you that much, he told a group of people. So he suggested instead steam inhalation as a preventative for COVID, which is actually, I think, technically regarded as rubbish. But this is a man who's basically pushing this particular thing to say steam inhalation is a homegrown cure, therefore it keeps me very proud of Tanzanian steam inhalation, which I presume means just sticking your head over a boiling water and putting a tea towel over your head or something like that. His own ministry is saying that, the vaccine should be actually taken. One of the issues that he's using as evidence is that their COVID rate is very low. And one of the problems is they've never actually reported COVID numbers since about May of last year. So no one has any idea of how prevalent COVID-19 and deaths from COVID-19 are in Tanzania. So really, this is a classic sort of sticking your head in the sand. It reminds me of South Africa, which regarded
HIV,
HIV as a plot to hurt Africans, and therefore they did a big campaign against any activities to stop HIV, and they got hit with heavy HIV infections. So this is sort of politics overriding medicine in a very dangerous way.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.